Hello guys, welcome back to my channel, Memo African Motives. Still working on mathematics N1, so we are going to have a continuation again, working on the question papers and revisions. So in this case we shall be focusing on the question paper which was actually written in March 2018. So we shall rush through the questions and see how we're supposed to answer these questions. So actually it's a 3-hour paper which consists of 100 marks. So we are asked on the first question there. In fact, the first question is carrying 15 marks. So the first question is to simplify each of the following without using a calculator by using exponential laws. So that is the question there, guys, that we are given. The first part on 1.1, that is a to the exponent of 3 to the exponent of 2 multiplied by a to the exponent of 4, and you've got 2 marks for that. Okay, so we actually know that whenever you are given a condition where there is an exponent, from our laws of exponents, if you are given x to the exponent of a to the exponent of b, you are going to multiply the exponents together. That is the law that we know from our laws of what? From our laws of exponents. So that means we can actually multiply this part here. So we've got 3 times 2, which is going to give us a 6. So we are going to be left with a to the exponent of 6 times a to the exponent of 4. Now at this stage we are multiplying. Take note here, we are multiplying and the bases are the same, so which means you're going to add the exponents. You're going to add exponents, which is 6 and 4. So if we add 6 and 4, you're going to obtain a to the exponent of 10. So you're simply adding 6 plus 4, which is 10. So that is what you're going to have in simplest form. So when you're given such type of equation, it's all about writing in the simplest form. That is the idea of every question. All right, so let's see another one which is on 1.12. that is this part. So I'm going to write it down so that we can see how we're supposed to simplify this. That's x to the exponent of 3 times x to the exponent of 5 over x to the exponent of 4 to the exponent of 2. Yeah, that's what we are having, and it's plus 3x to the exponent of 0, like that. All right, so what can we do in this case? If we are to cross-check, we are still back to the same part or the same laws that we had from the previous question, because here we are multiplying the bases which are the same. So we are going to add just like what we did. The same here. We are raising an exponent to another exponent. Remember, you multiply. So that is what you're going to have in this case. So which means we shall have, if we add 3 plus 5, that is 8. So it's x to the exponent of 8 over 4 times 2, which is 8. So it's x to the exponent of 8 plus. All right, we move on to this part here. I want you to take note, guys. Those terms that you are given, these are 2 terms. We have got 3, we have got x. This is the same as 3 times x to the exponent of 0, like this. That is what these expressions mean, this term mean. So we know that any number to the exponent of 0 is 1. So it's going to be 3 times 1, of which 3 times 1, that is going to give us a 3. So which means here we are going to have a 3. So that is what you're having in this case. Take note, guys, this is 3x to the exponent of, it's different from this one, 3x to the exponent of 0, like this. This one gives us a 1 because everything is going to be raised to the exponent of 0. But on this one, it's only x, which is raised to the exponent of 0. All right. Now on this part, you can actually cancel each other, or we can apply this concept that we are dividing the bases which are the same. So we know that we are going to subtract x to the exponent of 8 minus 8, which is going to give us x to the exponent of 0, like that, which is going to give us a 1. because any number to the exponent is 1, or you can just cancel because these are the same. So you're going to obtain 1 from this part here plus 3. So 1 plus 3, that is going to give us a 4. So that is what you're going to have. So it's wise that you do your separate calculations aside, then your working should be clear, so that these stages should be clear. Some of the workings you can actually do them separately, so that you show every stage in a proper way. So that is what we had actually. Let's see another part, which is on 1.13. all right, so that is 1.13. In this case, we are given to simplify this again, not using a calculator, guys. That is the major or the important part here, that you are not using a calculator. So the question was like this. All right, how can we actually simplify this type of equation? If we are to cross-check here, since we are not using a calculator, let's try and simplify this 25 here. What can we obtain from 25? We know two numbers can be multiplied, which is 5 and 5. 5 times 5, that is what? That is 25. So 5 times 5 actually means 5 squared. So 5 squared is equal to 25. So it means I can rewrite this as 5 squared, which is 5 to the exponent of 2, like this. But already there is an exponent which is there of half this one. So we're going to raise to the exponent of a half. All right. What about the term on this stage here? Take note, if we write x to the exponent of a plus b times 2, this one is the same as just a 1, like that. So just like you are given x, it is the same as writing as 1x. There is a 1 which is there, so which means you can multiply 1 times 2, which is going to give us, already we are multiplying, so we're just going to have our 2. 1 times 2, that is what? That is 2. All right. But we are given this condition where we are given a base and a base which are the same, and we are multiplying. So that means we are going to add the exponents. We are going to add a plus b and a minus b. So we are going to have something like x to the exponent of a plus b, like this. Then we add, and take note that when you add, it doesn't affect any sign, so you can just add direct, or you can open a bracket, still it's one and the same. But addition does not affect anything, so you can just write it like that. So you have added the exponents, this part here and this part together. All right, now we are back to the laws again of exponents, where we are given an exponent. Remember, we said we are going to multiply whenever you're given such type of a condition. So 2 times a half, that is going to give us a 1. So we are going to have 5. Take note, guys, this is 2 times a half, like this. So this can cancel, which means you're going to remain with 1. So it's going to be 5 to the exponent of 1. But 5 to the exponent of 1 is same as what? Same as 5. So you can just write it like that. Okay, times 2x to the exponent of here. We are now collecting like terms. So take note, we have got like terms, which is just 1a plus 1a. So it's, you're adding 1 plus 1, which is 2a. All right, here you've got plus b and minus b. So it's same as like 1 minus 1, which is actually 0 there. So which means you're just going to be left with 2a. All right, so we can combine these two, 5 and 2, which is 10. X is just going to remain like that, but raised to the exponent of 2a. So that is the condition actually, that what we had from this question. So it is important that you actually show the stages properly in each and every attempt that you are doing. All right. Let's see another question that we are given again to simplify without, because here we have to simplify each of the following logarithms without using a calculator. So take note, guys, the calculator is not required at all. You are not supposed to use a calculator. So what am I going to do? How am I going to simplify such type of logarithms? All right, let's just write the first question down. That's 1.21, where we are given the logarithm of 49 in base 7 plus the logarithm of 8 in base 2. All right. When you are not required to use a calculator, it is best that you use this law or this concept here. Let me show you in this stage. We know that this is a basic condition that you're supposed to know, actually, that the logarithm of a number in the base of that number gives us a 1. So knowing this condition, it can be very, very useful, especially on a condition that you can write this in the same base, because as you can note, we are adding, but these bases are not the same, so we can't multiply these numbers. So we have to work on a condition where at least we can make the number and the base to be the same, so that we can obtain a 1. This law is going to be accompanied together by this law, log m to the exponent of p. Let's say we are in base a, is going to give us p log m in base of a. So what does that mean? If you are given an exponent, you can drop the exponent to multiply the log by that exponent. These two are the same. So let's try and apply these two, guys, to simplify this. Okay, so how can we write this 49 in terms of the base? Because what we want is to have a number and a base. So what is going to guide you is the base. Already the base is 7. It's in its simplest form. So which means you are supposed to write 49 in terms of 7. So it's 7 to the exponent of what, which is going to give us 49. So you can try 7 times 7, and we say 7 times 7, that is 49. So it's 7 to the exponent of 2, which is going to give us 49. We are in base 7. So as you can see, we have written a number and a base which are the same. Okay. Plus, we move on to 8 and 2. So already 2 is in its simplest form. So we are supposed to write 8 in terms of 2. So it's 2 to the exponent of what, that is going to give us 8. So you can try 2 times 2, that is 4. Let's multiply again. 2 times 2, that is 4. 4 times 2, that is 8. So it means it's 2 to the exponent of 3. 1, 2, 3. So it's 2 to the exponent of 3, which is going to give us 8. We are in base of what? We are in base of 2. So what we need here, guys, is to have this number and this number to be the same. This number and this number to be the same. That is what we need. But there is an exponent here. There's an exponent. So we can't apply this law, because this law, as you can see, there is no exponent which is given. It's supposed to be a direct number and a number. So you're supposed to drop the exponent because of this law that we said when there is an exponent, you're going to multiply the exponent to the log. So let's do this. You're going to have 2 multiplied to the log. So it's going to be 2 log 7 base 7 plus, we drop this number 3, so it's going to be 3 log 2 in base of 2, like this. So once at this condition, we are done, because what we needed is this part, to have a number and a number which are the same to obtain 1. So we have got 7 and 7, so which means we are going to obtain 2 times 1, because this is all going to give us 1, plus the same here, 2 and 2, all this is going to give us 1. So it's 3 times 1, because we said log of a number in base of that number is equal to 1, is same as 1, not log 1, but a 1 which is a number without a log. So now that is what you're going to have. You're going to have 2 plus 3, which is 5. So that is what you're going to have at the end. So as you can see, that's how they ask these questions, guys. What you just need is to work along the question papers, match questions from your past exam papers, so that you'll be able to understand how they ask these questions. All right, so let's see another question that we had still on logarithms, which is 1.22. So this is 1.22. That's the logarithm of 2 to the exponent of m in base 2 multiplied by m, and we are given the cube root actually of 125, and we are given the logarithm of 100, like that. All right, and that's, if you could cross check 3 marks to that to give us a total 15 everything. So as you can see, that's a lot, guys, in exam. This one is a lot. So how am I going to simplify this type of a logarithm? If you are to cross check, still we have to apply some of the laws that we had here. This part where we are given an exponent, remember I said we can drop the exponent, so it's the same thing that we have here. So we can have our m multiplying the log, so it's going to be m log 2 base 2, which you know that log 2 base 2 is going to give us a 1. Okay, let's just leave it like that, times m. There's nothing that you can do to m, just leave it like that. But what do we have here? We've got the cube root of 125. All right, let's see what we are going to do. From our laws of exponents, we understand that if you are given the nth root of x like this, it actually means we are having x to the exponent of 1 over n. So which means applying this concept or applying this law, I can write this 125 here as 125 to the exponent of 1 over 3, because we are having x here, n and x is going to be x to the exponent of 1 over n, that is 1 over our n here, which is 3. But still 125 is not in its simplest form, so which means you're supposed now to be used to numbers and bases. So which number that you can use as a base that you're going to like multiply that number to obtain 125. So using these numbers, 5 times 5 times 5, we are going to obtain 125. So actually it means this 125 is the same thing as it's 5 to the exponent of 3 from 125. So if 125, this part that we are having here, is the same as writing as 5 to the exponent of 3. This is our 125, this one. But already take note, there was an exponent which we already have, this one of 1 over 3. So it's going to be to the exponent of 1 over 3, like this. So that is what you're obtaining from this 125. All right. We move on to a log now. Whenever you are given a condition where the base is not indicated like this, it means you are in base 10. So this is the same as the logarithm of 100 in base of 10. All right. So once we are having a base like this, so it means it's going to make sense, because there is one thing that we need from this concept, guys. We are still having this concept. We need to write a number and a number to be the same. So already we are now having a guided base, which is base 10. So it means this 100 in base of 10 can be written as log 10 to the exponent of 2. That is 10 times 10 gives us 100. But we are in base what? We are in base 10. Remember the concept that we all need is to have this part of having a number and a number to be the same. So we are given a number which is 100 in this case. Take note. So which means we can write as 10 to the power of 2. I hope you understand what I'm trying to say here. So it's going to be log 100, which is 10 to the power of 2 in base of 10 now, like that. So now we can apply our concept here, guys. Remember this concept that we want log a base a, that's a 1. So here we're going to have a 1. So m times 1, that is m times. All right, what are we going to do on this stage here? We've got an exponent and an exponent, so we're going to multiply them. So that's 3 times a third. Okay, that's gonna give us a 1 directly. This one, sorry. So you're going to obtain 1. So it's going to be times m. So this is a 1. So it's 5 to the exponent of 1, like this. So it's going to be 5 to the exponent of 1, which is same as what? Which is same as 5. Okay. Then here we've got an exponent, so we are going to do the same. We are going to drop the exponent, these two, to multiply the log here. So it's going to be 2 log, so you're going to multiply, that's 2. So it's going to be like this, 2 log 10 base 10, like this. All right, so we can just write it for the sake of us to all of us to understand like this. So we drop the exponent like this. All right, but we know that this log 10 base 10 represents 1 from the laws that we have been talking about, 5 times. So it's going to be m times, since we are left with 1, we are going to be left with m times 5 times 2. These are multiplying. A bracket means you're multiplying, so you can write it like this. So that means I can multiply the numbers together, 5 and 2, which is 10. M and m, remember the bases are the same. You're going to add the exponent. If the exponent is not written, it means there's a 1. So you're going to add 1 plus 1, which is 2. So it's going to be 10m squared. So that's how you can actually apply the laws of logarithms and together with exponents to solve such typical questions. It's not like we are going to have something which is direct. We've got different types of questions that we are going to meet, but the idea still remains the same on how to calculate or to work out such typical questions. Let's see this part on question 2. So we are asked to subtract the first expression from. So this is the guided word, this one, from, guys. This is where you're supposed to take note. The part that is given from is where you are going to subtract this expression, this one. So we are subtracting this expression from this. So it's going to be this expression minus this expression. That is what it means, okay? Let me explain in writing. So it's going to be 2.1. All right. So like I said, it's going to be this expression here minus this. So we're going to start with this expression from this. So it's going to be 2x squared minus 3x plus 5. Okay, minus, you subtract this expression, okay, which is going to be minus 7x plus x squared plus 1. So take note, this expression already have a minus. There's already a minus on 7. So just open your bracket, write the expression as it is with a minus. Okay, now you're going to expand the brackets. Okay, so let's try and expand. This one is just multiplied by 1, so there's no effect. it is going to remain as it is. It's just going to be 2x squared minus 3x plus 5 as it is. But this bracket here is going to be affected because there is a minus here. So it's going to be minus affecting every term inside the bracket. That is minus and minus, minus and a plus, minus and a plus. So that is going to be the effect there. So that means here we are going to obtain plus 7x minus and a plus, which is minus x squared, minus and a plus, which is going to be minus 1. So the minus is going to affect everything. So now let's collect like terms 2x squared and minus x squared. So there is the same as we are given a 1 like this. So it's 2 minus 1, which is 1 x squared, but 1 x squared is same as just x squared. All right, we have got this term minus 3x and 7x. So we are going to add this one you can just add even using your calculator this time, no problem. Minus 3 plus 7, which is going to give you 4. So you're going to have 4x. All right, then we are left with 5 and minus 1. So it's 5 minus 1. This one is going to give you a 4. So that is what you're going to obtain. So to simplify, guys, is you're just being asked to subtract there. So you're just subtracting, but make sure that the major part is here on brackets there. When you're working with the subtraction, you have to open brackets. The minus affects everything. The minus affects everything inside the bracket. So that is the concept. Then divide. Okay, so this time we are dividing this expression by, okay, so you know that whenever you're dividing, there's no way, guys, you have to apply a long division. But let's just rewrite this expression here because you're supposed to start with x cubed like this. It's going to be x cubed. This is followed by 5x squared, so it's going to be 5x squared. All right, followed by 7x plus 7x, followed by 2 plus 2. So that is the expression. You have to at least rewrite in a better way. So let's try and divide and see what you're going to have, guys. That is 2.2. Remember, when you're applying the long division, this part here is the one that you write inside this thing here. So it's going to be x to the exponent of 3 plus 5x squared plus 7x plus 2. All right, then you are dividing this by this part that you're dividing with is the one that you write here. So it's x minus 3. All right, so remember the concept of long division, guys, that you are supposed to divide whatever that you divide, you multiply back each term. All right, you subtract. Okay, then you repeat, drop that is drop terms, or bring down terms, then you repeat until you obtain a 0, 0, 0, 0, 0. Okay, so that is the actually the stages that you're going to just have 1, 2, 3, 4, 5. All right, so let's just see. So when I say divide here, you're going to divide the first term and the first term. So that's something like this. Let me just have it like this. So it's x to the exponent of 3 like this, divided by x. So that means you're going to have x squared, because it's 3 minus 1, which is 2. So you're going to have x squared. So this is what you write here on top, x squared. You multiply back each term. So you're going to multiply back each term here. So this one is going to be x squared and x. So if you multiply x and x here. X squared and x is going to be x to the power of 3, x squared and minus 3, which is going to be minus 3x squared. That is what you mean. So you multiply back everything here. All right. We subtract. So what are you going to subtract? What we have obtained here. You're going to subtract it. So it's x squared, x to the exponent of 3 minus x to the exponent of 3, which is a 0. So it's going to eliminate. So there's nothing there. And you have given a plus 5. So it's 5 minus minus 3. So that's going to be 5 minus minus 3 like this. And from your calculator, that's 8. So it's going to be 8 because it's a plus here. So it's 8x to the exponent of 2. So after subtracting, you have to bring down these terms. Drop these terms down. So you're going to have plus 7x plus 2. That is, you have to bring down the terms. Then we have to repeat. What are we repeating? This part of dividing again. Back, guys, the first term and the first term. So this time it's 8x squared divided by x. So as you can see here, there are 2. Here we've got 1. So if we divide, we're going to be left with 1x. But there's 8. So it's going to be 8x. So we're going to have plus 8x. We have divided. What do? We multiply back, we subtract. All right, so let's multiply back. It's now 8x this time, but multiplying back every term. So it's 8x times x, which is 8x squared. All right, then 8x times minus 3. This is going to give you minus 24x. All right, so you've multiplied back, you subtract. That's it. Multiply back, subtract. So you're going to subtract, guys. As you can see, these terms are the same. So once we subtract, they're going to cancel out. So this one is no longer there. You are left with 7x minus minus 24. So take note, is 7 minus minus like this, 24. So that is going to be a positive, which is going for something like 31 there, if I'm not mistaken. That is going to give us 31x because it's a plus now. 7 plus 24, which is 31. So it's going to be 31x. Then after subtracting, you have to drop the terms, bring down the terms. So which terms are you talking about? We are left with 2. So you're going to drop these 2. So it's going to be plus 2. All right. Then we repeat again until we obtain 0, 0. So we haven't obtained this. So we have to repeat. So let's repeat again. This term divided by this term. So it's now 31x divided by x. As you can see, x and x this time they just cancel. We're going to be left with constant 31. So it's going to be plus 31. All right. So in this case, if you multiply, it's going to be 31 times x, which is going to be 31x. 31 times minus 3. So it's 90. 31 times 3 there, which is going to give us 93. So it's going to be minus 93. Okay, we subtract like this. So 31 minus 31, that's a 0. 2 minus minus, so it's going to be 2 minus minus 93 like this. So it's going to give us a plus. So 2 plus 93, which is 95, which is just a 95. So this time, guys, take note, we are having a constant term. There is no x, so that is your remainder. So this time, this is not this one is not a factor because it is giving us a remainder. If it was a factor, it was going to give us 0, 0 in this case, but this time you're obtaining a remainder of 95. So you just leave it like that. So these are the stages that we're supposed to take. So whenever you obtain 0, 0, it means it's a factor. If you obtain a certain number like 95 or whatever number that you can get, it means that was not a factor. Okay, so that's how you are supposed to do it. But the stages which are important, these ones. Okay, then determine the product and simplify. So the question is the product. So the product is just expanding brackets there. All right, so that is the product, guys, to multiply the 2, which is 3a minus 5 into 3a plus 5. So someone can actually recognize that this is a difference of two squares, but let's say you didn't manage to find that, you have to multiply. So how do you multiply this? So it's going to be 3a and multiply to 3a. So 3 times 3, that is going to give us 9. A times a, which is a squared. All right. You move on to 3 and 5. So it's 3 times 5, which is 15a. Okay, we are done with these three. As you can see, 3a is multiplied every term. So we're going to move on to minus 5 this term. So it's minus 5 and 3a. So it's minus 5 times 3, which is minus 15a. Now minus 5 and plus 5. So it's minus and a plus, which is a minus. 5 times 5, which is 25, like this. So we have expanded, guys. So what is left? Are there any like terms? Yes, the like terms are there. This part here, the middle term here, they are like terms. So what am I going to do? 15 minus 15, that is 0. So which means I'm just going to be left with 9a squared minus 25, because this part is going to give me a 0. So I'm just going to be left with 9a squared minus 25. So that's how, guys, these two work hand in hand. You're supposed to understand the concept. The concept is very, very important, because expansion of brackets, then simplifying, because the question here is determine the product. So it's not about the product only, but and simplify. After that, you must simplify. So that is what is important there. All right. Then question 3, factorize each of the following fully. This time it's on factorization. So you're just going to write them down and see how we're supposed to factorize these typical expressions, because it's very, very important to know how to factorize. Okay, so let's write this part here. We are now on question 3 and 3.11. So sometimes they just want to test you. Sometimes how you respond to factorization. Okay, if we are to cross check here on this part, do we have any term which is common like throughout? So let's see here. We've got this number here 4. Seeing that 4, we've got 4 is there also, 4 is there also here. So which means we can factor out 4. Here we've got a is there, a is there, a is there. So you can factor out the list now, which is a. So you can factor out 4a. So that means we are going to divide. Remember, when you factor out a term, you're going to divide. That's going to be 4a to the exponent of 3 divided by 4a. So 4a and a is going to give us a squared. So inside this bracket, you're going to be left with a squared. All right, minus, you do the same, minus 8 divided by 4, which is 2. A squared divided by a. So you're going to be left with a and b. So it's going to be ab plus here 12 divided by 4, which is 3, but there's a plus, so it's going to be plus 3. As you can see, a and a is going to cancel, so which means you're just going to be left with this part, of which we can't factorize further. Why? If you are to cross check here, there is ab, and here we do not have a b, so which means we're just going to leave our answer like that. But if there was maybe something to do with b, then we can now cross check which part can we use to simplify further. But in this case, that was it. There's nothing that we can do. There is nothing at all. What about this one, guys? What type of an expression do we have there from this part here? Okay, let's just see. Let's see, guys. Sometimes it's a matter of seeing what you're given and starting from there. because it's not always a condition that you're going to be given something that you are familiar with. All right, so there we've got 4 marks for that, so which means there's something important that you're supposed to note here. All right, what am I going to do in this case? I know that I don't have any type of factorization so far that is to the exponent of 4. If it was to the exponent of 3, it was going to make sense. But to the exponent of 4 as the highest exponent, I do not have that. So that means I can group these terms so far. Okay, so trying and grouping these terms like this, we are going to be left with 2. So what can I factor out from these 2 expressions that is the highest common factor? So the highest common factor, if we are talking about terms like x, is the one with the smallest exponent. So you're going to factor out x to the exponent of 3, the one with the smallest exponent, into, if you factor out x to the exponent of 3, here we've got x to the exponent of 4, which means there are 4, and you factored x to the exponent of 3, you're going to be left with 1x plus 1. Take note, what is common is what you factor out, the highest common factor. But we are left with 2 terms here. And what is common in these 2 terms? You can see that we have got 4, we have got 4, so you can factor out 4. The moment you factor out 4, you're going to be left with 4x divided by 4, that's x plus 4, and 4 will cancel. 4 divided by 4, that's 1. So you're going to be left with x plus 1, which is now an advantage because we know that once these brackets are the same like this, you can factor out that bracket which is the same, which means you can factor out x plus 1 because it's common. So we've taken out this bracket, you have factored out x plus 1. So what are you going to remain with? You're going to remain with x to the exponent of 3 plus 4. So this is what you're going to remain with at the end. So as you can see, we can't go further from this part. We can't like factorize any further. That is how you can just leave your answer as. So yeah, that's how they can test you. It's a matter of test. Remember guys, exam is a matter of testing each other there. Okay, simplify the following. Okay, so you're given these expressions to simplify. All right, so I'm gonna write it down again. So that's 3.2. We are given to simplify 3x plus 6 over 6 divided by that's x squared plus 2x, everything over 2 like this. All right, so I usually say that when you are working with division, don't make a risk there. Try by all means that the first thing to do is to remove the division that you are given here. That's the first thing that you're supposed to at least do. So what's the concept? I know that the moment I introduce multiplication, I'm going to invert the second fraction, to interchange the second fraction. So that means this can be written as 3x plus 6 over 6 multiplied by, the moment you introduce multiplication, this is going to interchange. So it's going to be 2 over, this one is going to be written in the denominator now as x squared plus 2x. So that means we have a lot to do now. All right, which part can we simplify? We have to factorize at least, so that let's see here. 3 is common, so you can just factor out. Okay, this one is direct, so I can just write it direct here. So this is going to be 3, which is direct because it's common. So if you divide 3x divided by 3, that's going to be x. 6 divided by 3, which is 2, like this. All right, divide to 6 multiplied to 2 over, here we've got x again, which is common, so you can factor out x. So if we factor out x here, we are going to be having x squared divided by x, which is x. 2x divided by x, which is going to be plus 2, like this. So this is what you're going to have at the end. Now let's try and play some magics here in terms of cancelling whatever that we can cancel. Remember, whenever you're cancelling, it's always a condition of the numerator versus the denominator. That is the condition that you can cancel. So which means I can cancel this x plus 2 and this x plus 2. All right. We have got 3 and which is 1. 3 into 6, which is 2. So 2 and 2, that's 1. 2 and 2, that's 1. So which means we can cancel like almost everything. So as you can cross check here, on the numerator here, which is on top, we are left with 1. 1 times 1, which is 1 over 1 times x. Here we are left with x. So it's 1 times x, which is x. So our answer is just going to be 1 over x. So as you can see, it's a matter of introducing the multiplication sign. Once you have got your multiplication sign, then take note about what? Factorizing and so forth. All right, so that was the condition. Actually, let's see other part that we are given, which is on 3.3, we are asked to determine the lowest common multiple and the highest common factor. All right, so take note about this part, guys, the LCM and the HCF. Using prime factors, so we're asked to use prime factors on our answers. Okay, so that is what is important in this case. So how are we going to determine the HCF and the LCM using prime factors? Which means we have something to work on. Let's just write our numbers. Let's just write our numbers here. We've got a 3.39 a squared bc. All right, so let's start with this part here. If you are to write this 9, you are going to note that if you multiply 3 and 3, you're going to obtain 9. Or you can actually use this concept here. Start with the prime factor, which is 3. 9 divided by 3, that is 3. The prime factor that you can divide here to 3 is 3 again. So it's 3 divided by 3, which is 1. So as you can see, 3 times 3 actually is going to give us a 9. So 3 times 3 is the same thing as writing as what? As 3 squared. So which means I can write this as 3 squared by a squared by bc. So you can just write it like this. All right. We have this part of 12 here. So you've got the same thing again. So this is 12a to the exponent of 4, b to the exponent of 5, c to the exponent of 4. All right. So 12, we're going to start with you can just try 3. 12 divided by 3, that is, you can just write 2. 2 is the smallest, guys. 12 divided by 2, that is 6. We try 2 again. 6 divided by 2, that is 3. So as you can see, 2 cannot, so you're going to use 3. So we've got 2 times 2 times 3, of which 2 times 2, that is 2 squared, times 3, which is just same as 3 to the power of 1, or 3 to the exponent of 1. So there's nothing much there. And this part you're just going to write as it is, which is a to the exponent of 4, b to the exponent of 5, c to the exponent of 4, like that. Just going to write as it is. Then we've got 15, that part with 15, a to the exponent of 3, b to the exponent of 3, c to the exponent of 2. All right, so what do we have here in 15? So this is just 3, the smallest is 3. 15 divided by 3, that's 5. And you try 5. 5 divided by 5, that's 1. So you've got 3 and 5 there. So it's just going to be 3 and 5, which means we can write as 3 to the exponent of 1 5 to the exponent of 1, and this is just gonna repeat as it is. A to the exponent of 3, b to the exponent of 3. There's no need for you to simplify or write this. What is important is to have these as prime numbers, these ones as prime numbers, and so forth. So now what is going to be the LCM? Because that is the question. All right, so starting with the LCM, right, remember the LCM, which is the lowest common multiple. You take all the terms which are present, all the terms which are present. But in this case, we've got a 2, which is to the exponent of 2. So that is the only part which is appearing in terms of 2. So you're just going to take this part as it is, which is 2 to the exponent of 2 times. We move on to 3. So here for 3 now, we have got 3 here, we have got 3 here, we have got 3 here. So if the term is common, you're going to take the one with the highest exponent. For LCM, you take the one with the highest exponent, which is 3 to the exponent of 2. I think I talked about this from the previous question papers that we are working about, that you take the highest exponent for LCM. Then we have got 5. It's appearing, which means we have got to take this 5. So you're going to multiply by 5. You take all the terms which are appearing. All right. So that's a 5 there. Times. We are now, as you can see, these terms, they are all common. A is common, B is common, C is common. So like we said, we are going to take the ones with highest exponent for LCM. So which A has got the highest exponent is this A to the exponent of 4. So we're going to take A to the exponent of 4. What about B? We have got B to the exponent of 5, the one with the highest exponent. C, we've got C to the exponent of 4. That is the one with the highest exponent. All right. So you're going to multiply these numbers, 2 squared times 3 squared times 5. These numbers are going to give you 180, if I'm not mistaken there. Then just write as it is here, A to the exponent of 4, B to the exponent of 5, C to the exponent of 4. So that is what you're going to obtain as your LCM. But the highest common factor, I talked about this last time, that the highest common factor, guys, is something that is common throughout. So 2 is not common, so you can't take these 2. But 3 is common. We've got 3 here, we've got 3 here, we've got 3 here. But this time you take the one with the lowest exponent, the smallest. So which means you are going to take 3 to the exponent of 1, which is the same here, of which 3 to the exponent of 1 is same as 3. All right. You move on to A. A is common, A is common, A is common throughout. But the one with the smallest exponent is this one, A to the exponent of 2. So it's going to be A to the exponent of 2. You move on to B. The one with the smallest exponent is this one, which is B. For C, it's just C. So that is what is going to be your HCF. So HCF, you take the part with the smallest exponent. LCM, you take the part with the highest exponent. So that is what you're supposed to actually have as a concept that you're supposed to know in exam, because they are going to ask questions around such type of a question. So everyone is supposed to be very, very clear about it. Okay, then we have got question 4, where we are asked to solve for x. So the first one is a linear equation. As you can see, it's a linear equation. So it's just a matter of collecting terms there. So that is 4.1. We were given 4.41. That's 5x plus 3 is equal to 2x minus 3. So there you're just going to collect your terms, like terms, collect the terms with x to one side of the equation, and so forth. So that's how easier it is. So just transpose here. So 2x is going to be a negative, so it's going to be 5x minus 2x. We take this plus 3 to the right hand side, it's going to be minus, because then when a number crosses the equal sign, it changes its sign. But already we are given minus 3 on this side, so we're going to start with minus 3. Then this plus 3 is going to be minus 3 on the other side, because it has crossed the equal sign. All right, so 5 minus 2, which is 3x, is equal to minus 6 minus 6, minus 3 minus 3, which is minus 6. From your calculator, you can just know this one, guys. Just add the numbers, then you take the common sign. Then actually you're supposed to divide by 3 so that you can obtain the value of x, which is going to give us minus 2. So that is the concept there, guys. On working with the equations, it's a matter of collecting the terms depending on the type of equation that you're given. So this one is actually a linear equation, so that was the concept. Just collect the terms of x to one side of the equation, then you can simplify. Then still the same thing here, but we're given brackets and so forth, but it's still one and the same thing. So it's 3 into x minus 2 minus x plus 1, which is equal to 3. So we've got the same thing there. We've got multiply, expand brackets, that's 3 and x, which is 3x, 3 and minus 2, which is minus 6. 3 times x, 3x, 3 times minus 2, minus 6, minus times x, which is minus x, minus times minus 1, minus times plus 1, which is going to be minus 1. So the minus is affecting this whole bracket, which is going to give us 3. All right, let's try and collect like terms, but before, let's just work this left hand side only. So this one is same as we've got 1x there, so it's 3, take note here, 3 minus 1, which is 2x. Then we've got minus 6 minus 1, so this is just the same thing, guys. There's no effect, there's nothing, all the numbers are on the same side, so you can just add them, which is 7, but there's a minus. So that is the concept. So we're going to have minus 7, which is equal to 3. Now we can transpose this minus 7 to this side. So it's going to be a plus 7. So that means 2x is equal to 3 plus 7, which is 10. And you can divide by 2, guys. As you can see, your x is going to be a 5. So that was the concept there. That's how they can ask these questions different ways and platforms. So you're supposed to be very, very clear and careful about each stage. Okay, well, number 4, we are given that the sum of 4 consecutive even numbers. Okay, these are consecutive. All right, the first part is consecutive, then even numbers is 76. All right, find the numbers. We are given sum of 4 consecutive even numbers. What are these consecutive numbers? Okay, we know that actually consecutive numbers, these are numbers which follow a certain pattern, which is separated by a certain difference, which is the same. Just like we've got 1, we've got 2, we've got 3, separated by 1. So as you can see, as being consecutive. So if we are referring to maybe consecutive even, this one is even numbers now. So consecutive, let's just take an example like this 2 is an even number. So you're going to have 2 followed by 4, followed by 6, followed by 8. So these are what you are referring as consecutive, followed by. So this time you're only talking of even numbers. Okay, so there is something that I want you to take note. 1 is not an even number. It's just an odd. So if you multiply 2 times 1, you obtain 2, which becomes an even number. So let's say we want to obtain an even number in this case. let's say our number is x. Let's say we have got x, which is not an even number, just like 1. All right. Let's say that is our first term that we're talking about, x. An even number, which is 2, can be obtained by 2 times 1, which is 2. Just the same thing as 2 times 3, which is 6. So if you multiply any odd number, that is any odd number that you can have, if you multiply any odd number by 2, it is going to give you an even number. I hope it's clear. So that means if I multiply this by 2, I'm going to have 2x, which is now an even term. So here we want to calculate the value of the number. So we are going to let 2x to represent the first even term. Let's say this is our first even term, 2x. All right. Now I want you to see something from this part. How are these terms separated? Okay. The first part here, since they are even numbers, you're going to see here they are separated by 2, separated by 2, separated by 2, separated by 2 throughout. So which means all even terms are separated by 2. If they are consecutive, all even terms will be separated by 2. Okay, so this is going to make us form an equation now, because we are saying the sum of 4 consecutive is 76. So sum, that is, you are adding. So we are going to formulate an equation from that. Remember we said 2x is going to be our first even term. All right. So this is 2x. All right. So we're going to take 2x, which is our first even term. But what are we going to do with this 2x? This is what is important. There's a difference of 2. So the second term is going to be 2x plus the difference, just like this is your first term, this is your second term, this is your third term. So the second term is going to be 2x plus the difference of 2. Okay, so we're going to have plus 2x plus 2, which is our second term here, plus, remember we are said sum of 4. So we need to add up to 4. So what is going to be our third term? From 2x, which is the first term, what is the difference now to the third term? Yes, we have got a difference of 2 that is going to be there, but it's now 2 plus 2. So we are now having a difference of 4. So it's going to be 2x plus 4, because this is added from the first term to obtain 6 from the first term as 2 plus 2 plus 2, which is 4. So this one is going to be 2x plus 4. Take note on this one. Then we are now having the first, the second, the third. So we need the fourth term. So it's going to be 2x plus the fourth term is going to be having a difference of 2 plus 2 plus 2, which is 6. So it's going to be 2x plus 6. So these are the terms, guys, that we added together. 1, 2, 3, 4. And when we added these terms together, we obtained 76 from this part here. We obtained 76. So that means you have formulated an equation that you are supposed to solve. Formulated an equation that you're supposed to solve. So let's solve. We can just remove our brackets. As you can see, we are adding, so there's no effect. We're just going to write as it is 2x plus 2x plus 2 plus 2x plus 4 plus 2x plus 6 is equal to 76 as it is. Then we collect terms 2, 2, 2, and 2 here. So it's 2 plus 2, that's 4 plus 2, 6 plus 2, which is 8. So it's going to be 8x. Then you add these numbers, that's 2 and 4 and 6. So it's going to be 2 plus 4, which is 6 plus 6, that's 12. So it's going to be plus 12, which is equal to 76. So that's 8x is equal to, so you can actually transpose here, minus 12, 12 to this side is going to be minus 12, so it's going to be 76 minus 12, which is actually 64, something like that. So to find x, you can divide, now you can divide by 8 by 8, so that means our x is going to be 8. All right, but the question was, guys, let's answer the question here. The question is, we are given the sum of 4 consecutive terms, even terms, which is 76 years. But the question is, find the numbers, which means we have found the value of x. So what are the numbers that we added to obtain 76? Which numbers are we talking about? Okay, remember we listed here the first term, the second term, the third term, and also here the fourth term. So we are just going to find the numbers now by substituting x. All right, so our x is 8. So that is going to be, so the numbers are going to be, the first term, or the first number is going to be 2x, which is 2 times x, which is our x is 8. 8 was the value of x. Yes, our x was 8, so it's going to be 2 times 8. All right, which is a 16. So we are going to have 16. Okay, let's just write 2 times 8, which is 16. All right, then the second term is going to be 2x plus 2. So it's going to be 2 into 8 plus 2. But already this is 16 plus 2, guys. Which is going to give us 18. Then we've got the third term, which is 2x plus 4. So as you can see, 2x is repeating. Already 2x is 16, so it's just 16 plus 4. So this one is just going to be 16 plus 4, which is 20. Then the fourth term is still the same, 2x plus 6, of which 2x is equal to 16. So it's just 16 plus 6. 16 plus 6, which is 32 there. So these are the numbers that we are having. It's 20. This is 2. So it's going to give us 22. Yeah, 2, 2. Hey, guys. All right. So as you can see, I've got a difference of 2, 2, 2. So this is 2, 2. So if you add these numbers, you must obtain 76. If you add just as a proof, we must obtain 76 there. So let's try to add, guys. If we don't obtain 76, then let's come back again and do the question together so that we'll see where we actually went wrong. Okay, make B to be the subject of the formula on 4.3. We are given that V, that's the volume. All right, the formula for volume. If you are used to these formulas, you can actually tell the formula there. So you're given V is equal to LBH. All right, then on 4.31 we are asked to make B the subject. Take note here, make B the subject of the formula. So this is direct, guys. What is happening? L and H, they are multiplying, so you can actually divide. So V is equal to LBH, so you can divide by LH. Since we want to make B, so you can divide by LH. So this can cancel, this can cancel. So therefore, B will be equal to V over LH, like this. So that is going to be your B. Because what you need is to make B the subject, and you are multiplying, so you can simply divide. Then if V is equal to 180, L is equal to 9, H is equal to 5, find the value of B. So this one you're just going to substitute, guys. Okay, so let's just substitute. Let's see what we are going to have. right, let's see here. This is 4.32. Okay, already our v is not our v, guys, no, our b is v over LH. This is already the formula for b over LH, like this. So what you're going to do is to just multiply, substitute v, which is 180. So, and also take note about the units there. So already this is cubic meters, this is meters, this is meters, so they are fine. So L and H, so this is LH, which is L times, LH means L times H, so it's 9 times 5. Take note, it's 9 and 5, so you're going to multiply 9 times 5. All right, so here we can just use a calculator, guys. Direct is going to be 180 over 45, which is going to give us 4. So this is B, which is also a side to obtain cubic meters, this, which means this one is in meters. So that's our B. So therefore our B is 4 meters. So as you can see, that's how these questions, that's how they ask, and you're supposed to be very, very familiar to these typical questions anyways. All right, then we are given on 4.4 that a vehicle uses 1 liter of fuel to travel a distance of 13 kilometers. How much fuel is needed to travel 494 kilometers? Okay, so this is a simple direct question from proportion. If it uses 1 liter to cover 13, what about in 494? So it's just going to be 494 divided by that's 494 there, divide by the number of kilometers, which gives us a liter. So we're going to multiply by 1 liter there. So 494 divided by 13, we're going to obtain something like 38 there, times 1, which is 38 liters. So this one is going to give us 38 liters, like that. All right, so that's what you are supposed to do on this part. So that's how they can ask this question. Like, then on question 5, you're given the equation, write down in the form of y is equal to mx plus c. All right, remember that is the gradient and y-intercept concept, this one. So okay, let's just write our equation of the line. This is a straight line, in fact. All right, the equation of the straight line was 2y minus 8x plus 4 is equal to 0, like this. Okay, this was your equation of the line. Now the question is to write down this. Take note, guys, the format here, y is equal to mx plus c. That is the format that you're given, which is the gradient intercept format. So we have to make y the subject in actual sense. So you're going to transpose every term to the other side of the equation. As you can see, y is on one side of the equation, all other terms on the other side of the equation. So minus 8x is going to be positive 8x. 4 is going to cross the equal sign, it's going to be minus 4. Every term is to cross the equal sign. This is 2y, but here we need y, not 2y. So what are you going to do? You're going to divide every term by 2. Just separate each and every term by 2, like that. So that means you're going to obtain y, which is equal to a divided by 2, which is 4x. Then you've got 4 divided by 2, which is minus 2. So that is going to be the concept there, where 4 is the gradient and c, and minus 2 is the y-intercept. All right. Then the question is determine the gradient of the graph. So as you can see, that is what I'm saying there on 5.12. Now they want you to determine the gradient. So the gradient is y, because m represents the gradient, and our m in this case is 4. So our gradient which is m is equal to 4. That is what the question is asking you. So the gradient is 4. Then on 5.13, draw the graph using a table. Okay, so there we are asked to use a table. So we are given the values of x that you're going to take from -2 up to 2. Then use the graph paper. That is what is important there on that part, that you're supposed to use a graph paper. All right, sorry for that. So what are you going to do? Actually, you must have a table there. There's no way you must draw a table, because you're given the values of x to work on or to work with. So let's just draw our table from the line that we are given here. All right, where did I put my ruler? Here. Okay, so I'm just gonna draw this table. I'm gonna see it. I'll see it. I don't know where I actually put this ruler, guys. But anyways, that was the case. Like xy like this. This is where you're going to have your table. So you're going to have the values of x, which is the ones that you are given. And take note, this is on the line of y is equal to the one that we have made the subject. We obtained 4x minus 2, remember, guys. So we are going to start with -2 up to 2. So it's -2 minus, we are already given the values of x here. So that's -2 -1. You just write these values as they are: -2, -1, 0, 1, and so forth. So we've got 0, we've got 1, and we have got 2 there, something like that. All right, so this is what you're going to have. And we have to find the values of x. So it's a matter of the values of y now. So it's a matter of substitution into the value of x here. We're going to substitute 2. So like y is equal to 4 into -2 in place of x, then -2. So it's going to give us -8 minus 2, which is -10. Okay, we move on when x is -1. So it's going to be 4. Substitute the value of x, which is -1. So it's 4 into -1 minus 2. So it's going to be -4 minus 2. 4 times -1. Remember, BODMAS, brackets first. Simplify brackets first. So -2 minus 4 minus 2, which is going to give us -6. When x is a 0, it's going to be the same thing. So it's 4 times 0 minus 2. So 4 times 0, that's 0 minus 2. And 0 minus 2 from a calculator, that's -2. When x is equal to 1, you do the same. You substitute there. So it's going to be 4 times 1 minus 2, of which 4 times 1, that is 4 minus 2, which is 2. When x is equal to 2, you substitute the same. So it's going to be 4 into 2 minus 2, which is 4 times 2, that's 8 minus 2, which is going to give us a 6. So that is what our table was going to look like. So it's a matter of substituting there. It's a matter of substituting. All right, so that was the question here, to draw the graph, but we need to draw using this. So use graph paper. So now we've got the table, so we need the graph now. All right, so this is how it is going to look like. I just want you to see, because now the table, remember, using the graph paper is all about the idea there lies on the values. Are they going to correspond? That's what is important. All right, so from this part here, this is what you're going to at least have. If you are to cross check, you just need the x and you need the y there, indicate your values. So depending with the graph paper that you are using there, this is -2, -4, 2, 4, 6, and so forth. So it will be depending the part that you are given. But as you can see, this one that I'm having, so you just input your information there. So it's just a matter of marking -2 versus -10, -2 and -10. So it's like -2 here in x and -10 in y there. So -2 here, -10 here. So where these two meet, they meet at this point. -2 here and minus 10, they meet at this point. So where these two meet, that's where you mark a point. So that is only the concept. Okay, so you indicate, you mark all these points, minus 1 and minus 6. So minus 1 you just find in between 0 and minus 2, in between, then minus 6. So you can count 5 boxes, 1 2 3 4, depending with the graph paper that you are using, but it's going to be in between 0 and minus 2, and it's going to be under minus 6, like that. Okay, then we've got 0 and minus 2. So x is 0, y is minus 2. So you mark at minus 2 in y, that's the point. Then you've got 1 2. So x is 1, which is in between 0 and 2. So that's at this point, and y is 2. So we've got x, which is 1, and y, which is 2. So where these two meet, so it's 1 2 3 4 5, just in between, depending with the scale and the graph paper that you are using. But what you just need is to mark these points. Then 2 and 6, that's 2 and 6. X is 2, y is 6. They meet at this point. So it's important, where these two meet, you mark a point. Then using these points, you're going to join them. This point, join to this point, to this point, to this point, to this point. So these are the points that you're going to join, guys. This one is this one, and this one, and this one. So these are the points that we are going to join. So you just join these ones using a ruler, because it's a line, a straight line. So it can be joined using a ruler, and you are supposed to use a pen. So I'm just using a pen so that you see clearly what I'm trying to represent. So that is going to be your straight line, and you can write down your equation. Y is equal to 4x minus 2. All right, so that is going to be our graph, like that. Then another question, still on question 5, is now to draw the graph of y is equal to minus 4 over x on the same system of axes used in question 5. This one. Start by completing the table below. So we need to complete the table first, just like what we did, guys. All right, so we're just going to substitute here. Take note, it's minus 4x. So this is y is equal to minus 4 over x, like this. So at first, x is minus 4, guys. So you're just going to substitute, just like what we did. Minus 4 over minus 4 from a calculator, that's going to be positive 1. So this one is going to give you positive 1. Minus 4 over minus 2, which is positive 2. You do the same. Minus 4 divided by minus 1, which is positive 4. Minus 4 divided by 1, this time it's minus 4. Minus 4 divided by 2, which is minus 2. Minus 4 divided by 4, which is minus 1. So you can actually use your calculator at that stage. So I want you to just try and use your calculator, guys. Okay, at least we can be together in this one. So now, according to our table here, let's try to sketch now, because we are only given these few points, guys, and we're supposed to make use of these few points that you're given. That's minus 4 and 1. So it's minus 4 and 1, which is in between 0 and 2 here, because it's minus 4 for x. So you can just count in between 0 and 2. That's 1 2 4 5, according to your scale and the graph that you're using. But according to mine, this is the point 1, because it's in between 0 and 2 at this point here. So that's minus 4 and 1. We've got minus 2 and 2. Minus 2 here and 2. This is our point, minus 2 and 2. So they meet at this point. So you mark where these two meet or intersect. Okay, minus 2 and 2, they meet. Where they meet, that's where you mark the point. Okay, then minus 1 and 4. So you've got minus 1, which is in between 0 and minus 2 and 4 here. So I'm just going to count 5 boxes, 1 2 3, 4, 5, somewhere here. So in between, just make sure that you mark in between, so it's gonna be something like this. All right. On the other side, we've got 1 and -1, -4, 1 and this is now on this side, so it's 1 here and -4, so it's just with -4 here, 1, 2, 3, 4, in between, so take note, it must be in between 0 and 2, so somewhere here, but versus -4, so this is the point. Then we've got 2 and -2, that's 2 for x and -2 for y. They're going to meet at this point, so this is going to be the point 2 -2 here. And we've got 4 and -1, x is 4 and y is -1, so -1 is in between 0 and -2, in between here. So you can just count 4, 5, 1, 2, 3, 4, 5, in between, just somewhere here. Okay, somewhere here. So that's 4 versus -1, somewhere there. All right, so this is our table and we are supposed to draw the graph there. So as you can take note, the type of the graph that you are working with, it's a hyperbola, this type of a graph that you're given. So you're supposed to have this one, the y-axis and the axis as the asymptotes. So what I'm going to do, maybe to shift like this, maybe I can draw something which is nicer. Okay, so this graph is going to like try to approach to the x-axis, but it's not going to reach the x-axis. Then it's going back to this point, to this point, to this point. So it's best that you can actually shift your graph back like this. So it's going to be trying to approach the y-axis, but it's not going to reach the y-axis because the y-axis is the asymptote. All right, so this is the piece here that what you had on this side. All right, same side, same effect here. So it's going to be like this. It's going to be like it tries to approach the y-axis, but it's not going to approach, it's not going to reach the y-axis. So it goes back to the x-axis, tries to approach the x-axis, but it's not going to reach the x-axis. All right, something like that. So like I said, it's best for me to shift them. All right, but basically it's like this. All right, this is what I just did to draw, but it's supposed to look like this. So this is on this side only, then another piece on this side. So this cannot be joined. You don't join this one to this one, no, just like this piece here, this piece here, and the straight line. So you can just write the equation on one piece. Y is equal to -4 over x. It's very, very wise that you write down your expression to represent the function or the graph that you have drawn. This is the graph of something that is very, very useful there. So that is what we actually had on question 5. So you're supposed to be very, very careful with these typical questions, guys. Okay, so another question, actually there on question 6, we're asked to complete these ones. It's just a matter of working with it, guys. We know that these are the ratio. We are given that okay, let me just remove this paper beside. On this part, we are given that A, B, C is similar to, so you know that the ratio of sides is the same. So you are going to take here, it's AB over DE. So it's BC, so it's BC over EF. So it's going to correspond with EF. So it's going to be AB over DE, which is equal to BC over EF. So it's going to correspond with EF. Okay, then we've got AC. So you start with A and C. So this one is going to start with the D to F. So it's going to be AC over DF. So that's how you take these ones. BC, it's EF. AC, it's D to F. These corresponding, remember, for similar figures, the ratio of sides is the same. Then calculate the value of X. So X represents AC. So you're going to take any ratio here that is AC, this ratio here. Okay, so this is a 6.12. We are going to take this ratio with x. Where there is x, x is found on AC. So you're going to take AC over DF. Okay, AC over DF. Then you are going to equate to any of these. So you can equate to any of these two, either A, B, or whatever that you want. Okay, so in this case, I'm just going to use BC and EF. All right, you just take any of your choice. Okay, so AC is the one that is equal to X. So it's X over DF. D to F is 12. So you're going to substitute 12 here, which is equal to BC, which is 20, over EF, EF on this side, which is 10. So this is going to give us 10. So that's what we are having, guys. We can actually find the value of x there. We can actually cross multiply and so forth. So cross multiply, that's 10 times x, which is 10x is 12 times 20. Just multiply 12 times 20 like that. Then you can divide by 10 by 10. So that means our x can be equal to, that's 24. If you're not mistaken there. That is going to be the value of x, and it's a distance, this one, so it's actually in centimeters. Okay, so that's what we had on 6.12. It was a matter of working with similar figures. Okay, then on 6.2, complete the following and give the reason for your answer. Triangle KLM is congruent to, okay, for these two, which one is congruent? We've got two triangles here. All right, so remember, when you are referring to triangles which are congruent, it must have same conditions, guys. Same conditions. Okay, if you are to cross check, you've got a side and an angle which is in between and another side. This one is not in between, but this one is the case because we've got a side and angle which is between. So this one is the one that you're going to take. But how are we going to take this? KL is from the angle to the side L, which is from the angle, this side with 1 is the same side as this one, that is KL. So it's going to be triangle, as you can see, K to L from the angle here, so it's E to F, so it's going to be EF. That's how you take congruent triangles. Then LM, which is a continuation from this angle, L to M, which is F to D, so it's going to be FD like this. So it's going to be triangle EFD, triangle KLM. Take note, guys, we are talking about from K to L to M, according to what we are given. From K to L to M, from E to F to D. That is what's supposed to be the case. If it was LKM, this one LKM, it was going to be FED. That was going to be the case. But this one is not the way. It's not the way. And also it can't be DF anyway, because D, this side, is our last side, which is M here. So this is the condition that you are given there. All right, so the condition that we have for the congruency here, we've got side, angle, side. So it's just going to be, when you are given to find the condition of what, of congruency, you are going to have side, angle, side. Okay, then in this case, you are given that these sides, they are equal on 6.3. In fig below, triangle PQR is given that these all sides are equal. Calculate the size of R1 and R2. Give reasons for your answer. This is R1 here, and this is R2 here. All right. So take note, we know that angles in a triangle, they add up to 180, and these sides, they are equal, which means these angles are also equal. So that means this is going to be R1 plus R1 plus R1 is equal to 180 degrees, because this P is going to be like R1 is going to be like R1, because the angles are the same. because the sides are the same. It's an equilateral triangle. So it's going to be 1 plus 1 plus 1, which is 3. R1 is equal to 180 degrees. So dividing by 3, R1 is going to be 60 degrees. Why? Because we're saying angles in a triangle add up to 180, and this is an equilateral triangle. All angles are equal, so it can be 3 R1 is equal to 180 direct. You calculate R1, which is 60 degrees. So if R1 is equal to 60 degrees, which is this angle here, what about R2? R1 and R2 are on a straight line. So R2 is going to be 180 minus 60 degrees. Angles on a straight line add up to 180. So 180 minus 60, which is going to give us 120 degrees. So this is going to be our R2, which is 120 degrees. So that's what we had on question 6. So you have to be very, very careful with these typical questions. Then we are now given on question 7. On question 7. So all you need here is to just locate the quadrants, because you're given on 7 there that if sine theta is equal to 4/5, and we are given also the interval that is from 0 to 90 degrees, then the question is draw the rectangle triangle in the given quadrant, clearly indicate theta and the length of all sides. So you're given to give an indication of the length of all the given sides, then calculate the unknown side by using theorem of Pythagoras. All right, so let's just see from this information that we are given. In this case, we need to have a right angle triangle. So we are going to have something like this, guys, because we are working with quadrants. All right, so I'm just going to have my quadrant like this. This is a quadrant. All right, so remember how you name angles when you are working a quadrant, that you name your angles in an anti-clockwise direction. So this is your 0 degrees, this is where you have your 90 degrees, this is where you have your 180, your 270 here, then you are back to 360 degrees. So you are going in an anti-clockwise direction like that. All right, and this quadrant is the one that we are talking about, because it's from 0 to 90, so less than 90 degrees. So which means we're talking about this region from 0 to 90, this quadrant. This is where you are supposed to have your triangle in the first quadrant from 0 to 90 degrees. If it was 90 to 180, you're going to use this one, 90 to 180, 180 to 270, 270 to 360. So since it is the first quadrant, this is how your triangle is going to look like, guys. Take note, you're supposed to draw. It's a right angle triangle actually that you're going to draw. So you just draw something like this. That's a right angle triangle. All right, so you're going to have a right angled triangle like this. So the most important part that you're supposed to indicate is the 90 degrees in this case, to show that you're working with a right angled triangle. So that is where your triangle is going to be, and the theta is the angle that is between the positive horizontal axis and the resulting line, which is the hypotenuse. So this is the theta, this one. So that's your angle theta. All right, also we are asked to indicate, to calculate, clearly indicate theta and the length. So which means you have to indicate the length from this sign that you are given. Take note here, we are given that sine theta is 4/5 there. So which means we are going to obtain this from this sign that we are given. Sine theta is equal to 4/5. So what does this mean? Remember, sine theta gives us opposite over hypotenuse. So I also want you to work with these guys so that you can see from this triangle here. I want you to see something here. This is your theta here. So if you are given theta like this, sine is A over C, which is A over C, that is opposite over the hypotenuse A over C. So in this case, this is your A, this is your C, which is opposite over the hypotenuse. That is what it means. All right. So now let's put this into this triangle that you are given. This is our theta here, just like this theta. So our A and our C. So you're talking about this being our A and this being our C. So as you can see, it's sine A over C. So we said this is our A, this is our C. So we are going to have our A here and our C on this side. So we've got A, B, and C, or opposite over hypotenuse, like that. So which means you're supposed to calculate this, the third side, this one. So let's just say this is x for the meantime. So which means we can just apply our Pythagoras theorem. Okay, so remember Pythagoras theorem states that c squared is equal to a squared plus b squared, where c is the hypotenuse. That is the Pythagoras theorem here. So C is the hypotenuse this side. So A and B, these are the shorter sides. That's A, B, the shorter sides A and B. All right. So in this case, this is our C, which is 5 squared. So we shall have 5 squared is equal to A and B, which are the shorter sides. So the shorter sides, we've got 4 and x. So it's going to be 4 squared plus x squared. Since we want to find x, we are going to solve for x. All right, 5 squared simply means 5 times 5, which is 25, is equal to 4 squared. That's 4 times 4, which is 16, plus x squared. All right, now we are going to collect like terms, which means we are going to transpose 16 to this side. That's a minus. We're going to have 25 minus 16, which is actually going to give us a 9. So 9 is equal to x squared. So how do you remove the square? You introduce the square root on both sides. So which means your x is going to be square root of 9, which is 3. Yes, we know that square root of n number is plus or minus, but in this case, we are referring to x, which is a side. So which means we cannot have a length which is a negative. So this side is going to be 3, and it's on the positive side. So it's going to remain like that. So that is your triangle. So you're asked to indicate all the sides, 3, 4, and 5, angle theta, this angle of 90 degrees. So that is what you're supposed to indicate there. All right. So that was the question. So you're asked to calculate the unknown side using Pythagoras theorem. We did that. Okay, determine the values of each of the following expression now. 7.12, which is cos theta. Okay, so this was 7.11. All right, so that is where we have this diagram here that we are having this part. So now let's see what we have on 7.12. So we want to find the value of cos theta. Okay, so we are just going to back to our ratios here. Remember the ratios of theta. Cos, it's b over c. All right, so that is b over c, that is adjacent over the hypotenuse, b over c. So remember, this is your a, this is your b, and this is your c. So cos is b over c. So that is what you're going to use in this case. So cos theta is equal to b over c, which is equal to 3 over 5. That is, your b is 3, your c is 5. So you're done. That is your cos theta, just like that, guys. Just imagine, just like that. That is how they ask these questions. All right, then another one is tan theta. All right, so let's see the tan theta. That's 7.13. So tan theta. All right, so we are going back to this part here. Remember, tan theta is a over b. That's a over b, which is a over b, like that. All right, so tan theta is a over b, which is equal to our a. In this case, this is our a, which is 4, our b is 3. So it's 4 over 3. So as you can see, it's just a matter of substituting the value here, your A over your B, that is opposite over the adjacent. So you can actually know this by the ratios from SOHCAHTOA, like this. So you can actually know this sine is opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over the adjacent. So you can actually memorize them in that way. All right, another part that we are given is in triangle Q is 90 degrees. Okay, we are given 90 degrees here. PQ 60 centimeters, that's PR, and PQ is 30 centimeters. Calculate QR. This is QR, the side that you are calculating. All right, so we know, guys, there's no way it's a right angle triangle and you are given two sides. You want to calculate the third side, so definitely I'm going to apply the Pythagoras theorem. So remember, guys, our Pythagoras theorem, what it states, we said it's c squared is equal to a squared plus b squared. Okay, where c is the hypotenuse, which is c, that is, this is your c, this one, the longest side. A and b are these two shorter sides, so any can be your A or your B. So which means the longest side in this case is this one, which is 60. So this is your C. So it's going to be 60 squared is equal to A and B. These are the shorter sides, which is this one 30, and this one that you want to calculate, which is QR. Okay, so it's going to be 30 squared plus QR squared, the one that you want to calculate. So that means, guys, we can play around here with Pythagoras using the calculator. So what am I going to do? Let me just transpose this to this side so that it becomes a negative. Okay, so it's going to be 60 squared minus 30 squared is equal to QR squared. All right. Since I want to find the value of QR here and there's a squared, I'm just going to introduce the square root both sides, like that. Introducing the square root means we are actually getting rid of what? Of this, cancelling each other like that. So which means your QR is going to be the square root of 60 squared minus 30 squared. Okay, I can use my calculator at this stage. So if you are to use your calculator properly, you're going to obtain something like 51,961. That's 961 there. This is what you're going to obtain, and this is your QR, which is in centimeters. As you can see, all other measurements were in centimeters. So what is important, guys, is removing the square root. When removing the square here, you have to introduce the square root whenever there's a square like that. The moment you introduce this, these two actually cancel. You just remain with x. That's how you remove a square, which is the opposite. When you want to remove a square root, you have to square. If you want to remove a square, you put the square root. So it's one and the same thing actually. Then on question 8, we are given that in the parallelogram ABCD, AB is 13, we are given this side AB, and we are given AD. All right, AD, BT is 5, and AD is equal to BC. So we are given that AB and B, AD, this one A to D, and B to C. All right, so which means you have equal length here, and also AB, this one AB and DC, they are equal. So it means if this is 13, definitely this is also 13 centimeters. All right. Also here we said AD and BC are equal, so which means from A to B to D here is 20, which means from B to C here everything should be 20 centimeters. Okay, so and we are given that AT is perpendicular to BC, that is perpendicular. This one, there's 90 degrees, which means also this side there is 90 degrees. All right, so that is what we're given there. Then the first question is calculate the length of AT. Calculate the length of AT. So where are we going to have this length, guys? Which is this line here from A to T. All right, looking straight here, we can see that this piece here is a right angle a right angle triangle, this ABT. So look guys how we are working with these right angle triangles. This is ABT. So this is the part that I just want to remove from that. I'm just going to remove that part of ABT like this. We've got something like this. This is your A, this is your B, this is your T. All right, something like this. This is what we have here. So as you can see, this is 13, this is 5. From A to B is 13, which means it's the same thing here. This is 13 centimeters. This is 5 centimeters. And you want to calculate this side 80. So as you can see, guys, it's a clear right angle triangle. So we are back again to that concept of Pythagoras theorem. C squared is equal to A squared plus B squared. All right. That's in this case, C, remember, is the hypotenuse, which is this longer side, which is 13. So it's going to be 13 squared is equal to A and B. These are the shorter sides, which is this AT that you want to calculate, and this 5 that you're given. So it's going to be 5 squared plus AT squared. All right. So these ones, they are at least smaller numbers. I can simplify 13 squared, which is going to give me 169 is equal to 5 squared, which is 25 plus 80 squared. All right. Then collect these terms to the one side of the equation. You're going to have 169 minus 25 because it has crossed the equal sign, which is going to give us 144 equal to 80 squared like that. All right, so remember how you remove the square, you have to introduce the square root. So introducing the square root here, definitely it means something is going to happen. The square root and this one will cancel, so therefore I'm just left with 80. So 80 is going to be the square root of 144, which is 12 centimeters. So that is going to be our 80. So this is 8.11. All right, so that is what you actually needed in this case to have the length of 80. So as you can see that, guys, it's very, very important to understand the concept of Pythagoras. As you can see, it's repeating now and again, it's repeating now and again. So we can just indicate here our 12 centimeters. All right, we got our 80 there. All right, then the question is, determine the circumference figure ADCT. So we've got A, D, C up to T here. We just need like the circumference figure, which is a perimeter actually. Remember that perimeter, that is the circumference if you're working with the perimeter. But there's something here, guys, it's ADCT, all right, which is from A to D to C to T, this one, which means we are working with just only this part here, guys. Only this part is the one that you're working with, this one. That is the only part you're working with. Okay, so remember, if you're working with the circumference of the figure, it's actually the perimeter. That is the distance right round the shape. So the distance right round the shape, which means we are supposed to add everything in this case. So it's 8.12. So we're just going to have like C to indicate the circumference figure. So we're going to add, which is we're going to add AD, that's AD plus D to C, plus you add this one from C to T. Remember, this is T, so from C to T and T to A. So it's C to T and T to A like this. We have completed the quadrilateral ABCT. So it must AB, AD, DC, CT, and up to TA, because we need A, D, C, and to T like that. So it must go back to A, where it started from. All right. So which means you're going to add, this is 20, which is AD is 20 plus DC. DC is given is 13. Okay, plus. Okay, now we are going to see that CT is not given, because here we said 20, it's from B to C. This 20 here is from B to C. And from B to T, this is your T here, from B to T, it's 5 centimeters. So how are we going to know the distance from T to C, this one, from T to C? So since this is 5, we are going to subtract 5 from 20. So it's 20 minus 5, which is going to give us 15. So which means from T to C like this, we have got 15 centimeters. So this is the one that you're going to add, because take note, it's 20 from this point to this point, but you're given 5. So you remove this 5. To remove 5 is to subtract 5. That is 15. All right, so you're going to be left with 15 plus TA. From T to A, that is your AT, which is 12. Remember, this 12 centimeters, so it's 12 there. So this is what you're supposed to have, which is going to give us 60 centimeters. All right, that is your perimeter, which can be asked like the circumference figure, just like how they asked this one. So you must be careful of the language that they can use there. So that's what actually was there. All right, let's see this part on the last section. Calculate the area of the trapezium ADCT. Okay, so we are given the formula, this one, to use this formula. All right, so we need A, D, C to T. Remember, take note, from A to D to C to T. Okay, so using this formula, we are going to see that A and B, these are the sides which are parallel. This is your A, this is your B. So in this case, this is our A, this is our B. All right, and this H is the height, this one, which is the perpendicular height, which is this 12 here. That is your perpendicular height, the one that is at 90 degrees. But take note, you are working with A, D, C, T, which is that part only. Not this piece is not involved. This one is not there. We are just working with this A, D, C up to T. This is the only part that you're working with. Okay, so which means our formula is going to look like this, guys. This is 8.13. Okay, we are already given that to use this formula, A plus B over 2 times H. This is the formula that they gave us to apply. All right, so where A and B are those sides which are parallel. So in this case, this is your A, this is your B. So remember, our A is 20, our B is 15. So it's 20 plus 15. 20 plus 15 over 2 times H, which is the height. So in this case, our height is 12. All right, so this one is just a matter of substituting, guys, into the formula that you are given, then definitely using your calculator to simplify. Take note, this is one part, so you can actually put it in a bracket when you are using your calculator, because that is one thing. So you're going to obtain 210 square centimeters. Remember, this is area. So the area in this case, you can just write A for area, which is 210 square centimeters. Take note about that. All right, then the other part is decrease 320 kgs by 15%. Take note, a decrease, it's a minus. So which means you're supposed to find 15% of this, then you subtract. That's a decrease. That's a decrease, guys. Okay, so actually there are so many ways of working this type of equation, but I'm just going to explain one which is best. So we want to decrease by 15%. So this one is a decrease. So we are going to find 15%, which is 15 over 100. That's 15%, or 0.15, okay, of 320 kgs. So like I said, someone can use 15 over 100 like this, or someone can just use 0.15 times 320. Where am I getting this from now? Just 320 kgs. This is 320 kgs, like that. All right, using this or using this, you're going to obtain the same thing, guys, which is 48. So you're going to obtain 48 kgs, 48 kgs in this case. All right. But the question is, we are supposed to decrease 320 kgs by that 15%, which means by this 48, we are supposed to decrease. So you're supposed to subtract, which is 320 kgs, the one that you are given, minus the 15%. You're going to subtract 48 kgs. So that is what you're going to obtain, which is 272 kgs. So as you can see, guys, if it was an increase like this, which means you have to add, decrease, subtract. So that is the concept there. All right, then on 8.3 we are given that an item costs 700 rand before adding VAT. If VAT is 14%, calculate the total cost including VAT on the item. Okay, take note, guys, a VAT is actually a value added tax. Take note from the part that it's added tax. So before, something was costing 700 rand, which means there was nothing, there was no VAT. Most things, that's what they do in shops. You buy something, already there's a value added tax on something that you are buying. So now we are saying that there is a value added tax of 14%. So just like what we did, this one, it said added, this one was decreasing. So you're just going to find 14% of 700, just like the previous part. Then you add to 700, because it's an added tax that you're talking about in this case. Or we are going to have the opposite way of finding each part separately. So in this case, let me just do this. I think explaining at the same time writing can be better there. So we are saying 14% is the one that we are given. So it's 14 over 100 times the amount now, which is 700 rand. So we want to know what is going to be the value. So like I said, it can be 14 over 100, or it can be 0.14 times 700, like that. All right. So you are supposed to multiply the two so that we can obtain the resultant of 98. So this is going to be 98 rand here, 98 rand. So this is the amount which was added due to tax, which is the value added tax. So it's something that is not the price of an item. This is just a tax that is 98. So now what is going to be the value now, the total cost, including that value added tax, which is the VAT. So it's going to be the amount that you had of 700 plus the tax which was being charged. So we are going to obtain 798 rand. So the item is now at this price, but originally the price was at 700 rand. So I want you to cross check there an error which happened in your memo. They used a 13 there, which is actually a wrong concept, because we are working with 14 there. There's a 14, so it's just a printout error and so forth, and it affects everything. So, but as you can see, guys, that's what we had in this paper. As you can see, in order for you to have a total of 100, there is something that you just need to at least work on, revise on as much as you can, because that's how actually these questions might be. So till we meet again from Meson African Motives, let's just continue to share our videos to our friends and colleagues, also that they can benefit from this platform that we are having as a family of Meson African Motives.